So if you're looking at the back of the homework, let's walk through this together with number 4. And to be honest with you, there's more than one way to go about this. So if you see something different from me, that doesn't mean it's wrong, because there's more than one way. If we think about, if I said to you right now, hey, let's meet in the cafeteria in 10 minutes, what are the chances that you and I go the same way? From this room to the cafeteria, what are the chances that we go the same exact way? How many different stairwells are there for us to walk down? Yeah, at least 3. 4 if you go to the front of the building. So whether we start upstairs or downstairs or go down whatever stairwell or hit whatever hall, sometimes I walk out of my room and I go straight, sometimes I go right. You know what I mean? Sometimes I really like walking up Main Street, and sometimes I scoot and take the shortcut up to the office. Sometimes I cut through the library. I got to be honest with you. I like walking through the library. I like to see which kids are in the library. There's more than one way to get to where we're going. So you just have to make sure you understand my way and whether or not your way is right too. How about that? All right, let's talk about what we're given in this first one. I'm given the fact that NZY, QZY, MXY, and PXY are all right angles. So these are all right angles, and these are all right angles. Now I'm just writing down some ideas here. So if we're talking about what does that mean, I know for sure that that means that these lines are parallel because of those right angles. So I know right away that line segment PM is going to be parallel to line segment NQ. And that can give me all kinds of alternate interior angles conversations for sure. Let's talk about what I'm trying to prove. I'm trying to prove that triangle MYX, here it is here, triangle MYX is congruent to triangle PYX. So I know I for sure at least have a set of angles, because if this angle is congruent to this angle by alternate interior angles, and this angle are congruent, then I can have these two angles congruent. And I got to tell you something, I'm already done. Because once I have my alternate interior angles, and once I add in my reflexive property of congruence, do you see angle side or angle side? So there's a lot of other noise happening in that diagram that I don't even need. I don't need isosceles, even though I know they are. I don't need vertical angles. If I wanted to, I could talk about how these triangles are congruent. And then if I wanted to do some vertical angle conversation, I can. And they would be congruent too, but I don't need to, because I can get those triangles congruent through angle side. All right, let's talk about 5. So I'm given that these two angles are right angles, and I have segment RT is congruent to SV. I'm trying to prove that angle R is congruent, angle R is congruent to angle S. So if you are not already in the habit of pulling out these triangles, can I talk you please into doing it? Because if you pull out that triangle and if you pull out this triangle, it's going to make it super easy for you to see triangle RTV, and triangle TSV, recognizing that this side is a shared side, recognizing that these angles are both right angles, and it just gave me here that this side is congruent to this side. So when I'm talking about how do I get these angles congruent, it's definitely a CPCTC. Once I get the triangles congruent, triangle TRV is congruent to triangle, what is that, VST? And that's through side, angle, side. Then I go ahead and have my CPCTC. Any questions on that one? All right, let's take a look at 6. If I know that XY is congruent to WX, that's given here, and I've got ZX bisects angle W or YXW. So YXW, so by the definition of bisector, I know that these two angles are going to be congruent. So my job is to prove that segment YZ is congruent to segment WZ. Ideas for this one? If I use my reflexive property, I can get XZ congruent to itself. And then it looks like I can jump right ahead to my triangles. Triangle XYZ is going to be congruent to triangle XWZ. And that's by side, angle, side. So then I can use by CP, CTC, I can get YZ is congruent to segment WZ. Sound okay? Yeah.
This isn't actually related to the first, but could you argue that O is a right angle? Like all of the...
Yeah, so that would be a great thing for us to ask you to prove, because if you proved that these two little triangles were congruent to each other, let's talk about just these two triangles, Maggie. Then those angles, those corresponding angles where O is, would have to be congruent. And because they're congruent and supplementary, they have to be 90 degrees. So you could, a great thing to say is prove that X, Z, and WY are perpendicular. Right? I could say, hey, prove that those two lines are perpendicular because they're both congruent and supplementary. Yeah, that's a great question. All right, so